Okay. Now, I would recommend that you go back and look at the example in the textbook. It took me a while to figure out which one I wanted to do. I wanted to show you that example, but I felt like you could figure it out yourself just by looking at it. It's not that hard, it's just long. I was going to do question 5 with you guys, but I felt it was a little easy, so I probably didn't want to do that. I wanted to give you something a little bit more worth my time and worth your time. So I'm going to do question 7, and I think some of the wording with it is a little bit hard, and maybe I didn't say it clearly before, so I wanted to touch up on that. When it says find the relative and absolute maximum minimum, what I said before is true, but I guess within the confines of when we're setting a domain, is that when we're looking at this, we can have multiple maximum and minimums. So let's just say we got something really small. It goes little bump, big bump, big bump, much smaller bump, and we're measuring within this domain. This would be our absolute maximum, and this would be our absolute minimum. Therefore, these would be our relative, max, and min, or sometimes we call them local. I always got taught local. The textbook calls them relative, but they are the same thing. Okay, so we're working within the confines of our domain. For this function, it's 3x to the power 4 plus 4x to the power 3 minus 12x squared minus 3 between negative 2 and 2. So what's asking us here is, can you find, it might look something like this. Hopefully it doesn't, because we have 4 points. It's going to be a lot. Can you find the relative or local absolute maximum minimum values of this function? Okay, so it's asking, can you find all 4 points if there are 4 points? So I'm like, okay. Let's try and do this. So let's follow our methodology, and let's start with our stationary points, and from there we can start to build up. Okay, so 1, y, stick to what they have, f dash x. I'm going to say that's 12x to the power of 3 plus 12x to the power of 2 minus 24x and 3. F dash x is going to be 36x squared plus 24x minus 24. Okay, a little complex, but we'll see what we can do. Sorry, that isn't step 1. This is going to be step 1, which is make f dash x equals 0. So 0 equals 12x 3 plus 12x squared minus 24x. Okay, a few things. I'm going to divide everything by 12, and I'm going to put in terms of x. Okay, so I know one of them is going to be 0. I know one of my points is going to be 0. This is going to be 2 and negative 1. Hence, x will equal 0, negative 2, and 1. Okay, so we have 3 points. 3 points, 0, negative 2, and 1. And we've got to determine their nature. Before I do that, I should find the y values for them. I'll just quickly find them. Where x equals 0, y will equal 3, 0 to the power of 4, plus 4. It's just going to be minus 3, because that all goes to 0. Whoops. Okay, so one of our points is 0, negative 3. And next one, just going to do this, is going to be where x equals, let's say, negative 2. Y will equal 3, negative 2 to the power of 4, plus 4, negative 2 to the power of 3, minus 12. Oh, I'm going to run out of room. Minus 2 squared minus 3. I'm going to use a calculator for that one. 3 negative 2, power of 4, plus 4. Negative 35. Okay, I'm going to pray that's correct. Just going to double check because I do not want to do this again and make mistakes. 3, power of 4, 4, power of 3, minus 12, power of 2, minus 3. Okay, that should be correct. And whilst we got it all typed in our calculator, let's put in x equals 1. So let's just replace all these negative 2's with 1. We get negative 8. So 1 and negative 8. Okay, so we've got our 3 stationary points, and we've got to determine their values using this, our f dash dash x, putting in the x values, and we'll figure out if they're maximum and minimums, and from there we can find our endpoints, and then we can actually start to sketch it. I don't think actually we need to sketch this one. Actually, by the nature of the question, we just need to find out what they are. Okay, so let's just do it. Step 2, where f dash dash x equals 0. No, sorry, my mistake. Let's start with our 0, just here. Now, remember this is 30 f dash x, 36 x squared plus 24x minus 24. Okay, so when we put 0 into that, it's going to be negative 24. So that is less than 0, therefore it's concave down. It's going to be a maximum. Whether it's our local or relative max, we haven't figured out. By its nature, it's a very, very, very small number, so it could very well be our absolute, but we don't know at this point. Okay, if we're putting in negative 2, it's going to be 36 negative 2 squared plus, 24 negative 2 minus 24. I'm just going to put that in my calculator and keep that in there. $72. Okay, that's going to be concave up, hence it's going to be a minimum. Okay, and my last one, f dash dash 1, just going to replace these. It's going to be 36. Okay. So we have a, sorry, I should finish this up. Concave up. It's going to be a minimum. Okay, so now I'm going to have a bit of a stab in the dark here. I believe, well, obviously, this is going to be our absolute maximum, sorry, because there is no other maximum to contest with it. With this one, Now, we've got to do one quick step, our last little step, step 3. What's good about what we've done so far is we've found our stationary points and the nature of them, and that's fine. But what if our maximum value of x is not a stationary point? What if it goes beyond that? So let's just say, quickly draw a picture, just to help you explain. We've got our boom, 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 and it goes all the way up, and our domain sits here. That just there is not a stationary point, but it still is the maximum y value within this range. We have to take in our endpoints into consideration. So we've got to do step 3. And our domain is -2 and 2. So we've got to put those in, okay, into our original function. So let's find that. So our original function, just to recall, is this. Okay, let's put in f -2, because that was one of them. 3, -2 to the power of 4. Okay, -35. Which we already did. We should do our other one. Maybe 29. Okay. So now we've got some kind of points. Okay? I am just going to sketch this out just to make sense and explain it for you guys. Our points are going to be 0, -3. Our other point is going to be -2, -35. Let's go here. We're taking some liberties. Oh, probably here. The other one is going to be 1, -8. And then our domain, we've already done one of them, which is here, is going to be 2, 29. So it's going to look something like this. Okay, but it actually ends on that one. Oops. So here we've got a minimum value, another minimum value, a maximum, and a maximum in terms of where the function is progressing. So here we go, okay, we've got all these points, we've figured out their nature. What is our absolute and our relative, I guess, y values for that domain that we have set? Okay, let's go with the absolute max, and that is going to be this y value here, which is 29. Our absolute min will be this one here, and that was -35. Our local max was here, which was -3. And our local min, well, we've kind of got two mins within here. I would say that our minimum here would be -8. Okay, you can also write -35 because technically that is a minimum, but I would say this one accounts for both. This is a hybrid of this point and this point. This is the lowest y value, but it's also a stationary point, so you kind of have to put both of them in there. Okay? I hope that helps, guys.